Hi, everybody. I'm here to just make some announcements before we start week 2 of our Pendulum lab. I have posted to Sakai and on YouTube the videos I took of me carrying out procedures part B and C. So in B, we're trying to determine whether the initial angle of release affects the period in accordance with the model we talked about in class on Tuesday. And in part C, we're going to think about the effect of the mass of the bob on the pendulum period. Now, I've also posted the raw data, so I literally transcribed my lab notebook as a PDF on Sakai, so you don't need to try to listen to me say all the data. And because I think you can see how these measurements go, I only filmed me doing a representative subset of the measurements. Now, there's a very important thing I need to mention, something that didn't become apparent to me until I analyzed the data today. In doing all of the data taking in procedure part B and part C, I goofed up in a pretty serious way. I will say that all of the period measurements that I said in the video, that I wrote in my lab notebook, and that I have in that datasheet on Sakai are wrong in a pretty serious way. Now, they're wrong in a way that is fixable. I'm going to leave it to you to think carefully about what might be happening. And I'll make another video where I talk about what actually happened because it wouldn't be fair to just leave you to guess what happened. But you can maybe try to take a stab at it by watch the video. You can get a rough estimate of the period just by watching the bob swing and timing with a stopwatch. And you might be able to guess what happened to me when I tried to take the data. You're all good experimentalists, so I'm confident if you were doing this, you would not have you wouldn't have goofed. But the situation is quite salvageable. Okay. So due Tuesday for next week. There's three main things. There's the homework for Pendulum Part B. So there's a couple of homework questions in the homework manual. I also want you to generate a graph for procedure Part B. This time, please use a computer program like Excel to generate your graph. If you really want to use something else like Python or MATLAB, I'm happy to provide guidance here, but my default assumption is that you'll be using Excel to make your graphs. And then the third major item, which I look forward to reading, is your written report. So we're asking you for about 3 paragraphs. So 2 about procedure B and 1 about procedure C. We want you to, as it describes in the manual, write a paragraph comparing the predictions of the small angle model to the all angle model, the all angle model being the one we talked about in class this week, involving that integral you have to evaluate numerically. We also want you to write a paragraph comparing your measured periods to the all angle model prediction. For part C, what we'd like you to do is to write a paragraph where you summarize the theory behind part C, where you describe the method that we took or that I took, the data, and the conclusion. Now, this is a little bit less canned than it might appear because I actually took quite a lot of data for part C. You don't have to use all of that data. So it's entirely up to you what you choose to look at And so it's going to be really important that you describe what's going on in Part C and how you're choosing to analyze the data. Let me also just make it clear there's no graph required for Part C of this experiment. So just some thinking and some writing. And I'll be providing you with some feedback on your writing for Pendulum Procedure A as soon as I can, probably over the weekend. Now, there's one more thing just to look ahead. So for next week, we'll start the falling mass rotating pulley experiment. I'm not sure why we call it that. It's an Atwood machine with a massive pulley, but that's but whatever you want to call it. So what we'll do is we'll start the theory and the model development for that. If you had 117 with me last semester, you may remember that we did not end up having enough time to spend as much time on rotational dynamics as I would have liked. So I'll remind us of the basics of torque and angular momentum in class next time. So one last thing that I want to mention is that, let me scooch this up, so please complete the feedback survey I sent out a couple of nights ago, if you haven't. So I'll be reading those over the weekend and just thinking about what things we might do differently in the rest of the class and also for next year. One of the things that I'm asking you about in that feedback survey, I expect we may have a little extra time because FMRP is probably going to go a little bit faster in this remote format than if you were doing the experiments yourselves. So there's a thought of maybe having you do some measurements at home on something different, but something that might be kind of fun to still have a bit of a hands-on aspect, even in this unprecedented time of remote instruction. Okay, so thanks very much. That's all I have to say for now. Again, remember that I goofed up in taking the data for both parts B and C, and it's just, I goofed in exactly the same way. So it's only one thing. Do watch my video and see if you can think about what might have gone wrong. It took me a little bit of poring over the data. It wasn't clear until I started to analyze the data, in fact, that something had gone wrong. But have a think about it, and I'll make another video where I talk about what happened.